Alright, hello all, hello world. This is day 77 of studying compilers every day until I land a compiler role. I am really tired and I kind of just woke up from a nap, so today's stream might be a little bit shorter. There's also definitely just less content for me to try and go through today, but it's still hopefully going to be a good time. Yeah, I've got news that I'm gonna share sometime in the coming days, but I'll give it a bit. Just know that my daily streams are not gonna go anywhere, irregardless of whatever happens. Oh, that's good. That's good. I can't see usernames in chat, so this makes things very difficult to actually figure out who is who. Let's see if I can do something about that. Maybe if I pull up the YouTube stream manager? Let's see. That is... Okay, so that is... Okay. I guess I could have guessed that you're Akash from the... from the what's it called? The, like, YouTube tag? It's not like the username. It's, like, really cursed. Let me just pull up my stream on... Like, stream proper on the stream manager. Where does this live? Content? Let's see, live? Aha, there it is. Okay, live control room. Okay, that shows me just as little information. That is very irritating. Okay, well, whatever. I guess I'll deal with it. Yeah. So we're gonna tile some more trees today. Last time we started tiling trees. We generated some trees for some of the more basic instructions, but we have a couple more that I've kind of put off on just because I didn't want to work on them. Specifically, we want to tile the trees for call instructions, fee instructions, and then like the two different branch instructions. And I'm not really sure how to handle those, but we'll figure that out, I guess. Wait, they changed the icon for Word, or am I tripping? I don't know. I might be schizo. So real quick, in my Discord, I had this, yeah, I saved this image from last time. This is like the set of trees that we have written tiles for, and then the ones that I wrote at the bottom here are the ones that I still need to do. We're actually just gonna open this image up in Paint.net again. I know there's more efficient ways to do this than downloading the image every time, but we will deal with that. As in, I will do literally nothing about it. Yeah, so let's open up the code base. Yeah, so we have, we've added a couple of nodes. We need to implement all of these classes, all of the member functions. Member functions, I think, is the term. Yeah, it's hard to remember the actual names for things. Yeah, so we have visitors, I guess, like set up for everything, but we just need to actually fill them in still. So we completed the one for binary op, which was, I think, the most straightforward one. We have allocate, we have load, we have store, and we have return. Those are the ones we have done right now. So we have 4 more instructions that we need to generate trees for, and yeah, hopefully that's not too bad. So yeah. Okay, I'm gonna take a second to try and figure out if there's a way to make the chat not terrible for me to read, because it really sucks not being able to read usernames. Actually, let me just look this up. YouTube chat OBS usernames. Yeah, because I only see like YouTube tags, like the thing with the @ which is very much not usernames. Handles, is that what it's called? Yes, this is terrible. there a way that we can get rid of it? Switch from handles to usernames. Ah, okay. So it looks like there is just no way around this. This is really annoying. Yeah, it's actually, it's quite infuriating for me. Is there a way to like change anything there? Can I like supplement it maybe? Is there a way to do that? Let's see if I can I open up. Okay, YouTube is just giving me the worst time, I guess. Okay, that's my channel dashboard. Maybe I shouldn't share all of that. Okay, yeah, we're definitely just fighting with YouTube right now. This is what the next 10 minutes is gonna be, I fear. Is there like a stream settings somewhere? Channel. Permissions? No. Any moderation? This is, okay, this is very, very annoying. Okay, well, let's, yeah. This is all gonna be like off screen, so apologies if it's like a little bit boring, but I want to be able to chat with y'all with like your actual usernames and not have to deal with Chungus YouTube handles instead of usernames. This makes it actually very, very annoying to chat. And it really sucks for me. Okay, YouTube Studio. Let's go to, where does this live? Man, why does YouTube do these things? Time to write your own YouTube plugin? Yeah, that might have to be what ends up happening. Customization? No, it's not there. That's my actual YouTube stuff. It's not in settings. Where actually is this? Where does this live? Maybe it's in like the stream settings then? Like live control room? Huh. I can do anything but make chat reasonable, I guess. If I like, this really sucks. This actually really, really sucks. Yeah, that's a pretty big bummer. It's like, I don't know, how do I even describe this? It's like Twitch isn't capable of making a good product, and then YouTube could like do literally anything to make it not suck, and then they proceeded to like make a mess out of it. Okay, well, I guess I'll have to just deal with plugs. Or plugs? Tags. Handles, that's the word, yeah. So we'll have to deal with that, I guess, unfortunately. Apologies if I just like call you by your handles. Hopefully y'all understand, because I literally cannot see anything else. So, yeah. Okay. So the call tree, I guess, we can go back to what we were doing here. The call tree I held off on because it's kind of annoying. Because we have a function name and then we have, I guess, Actually, I think we just have a function name. And then we'd want to give it a couple of trees to like, I guess figure out calling convention stuff. So I need to like set up all the stuff for calling convention, which is also something that I guess these trees need to handle. Yeah. So let's take a quick look at calling convention real quick. So I remember that there are caller saved registers and callee saved registers. I do not remember much else than that. I also remember you have to like stick the parameters in certain registers as well. Oh, syscalls, I actually know what those are now. Is this what we want? Oh, full blind, okay. Oh, okay, everything is just gonna full blind me. Is this any help at all? Okay, maybe there's something that like gives it a nice image. This would, okay, maybe it's like easier if I just like look at slides from like from my intro to systems class. That might be very smart. Okay, I remember there are callee saved registers, there are caller saved registers, so we'd need to save the caller saved registers, I think. Or like we'd have to push the caller saved registers to stack. We'd have to move the parameters onto the various different registers, and then I think then we just do the call. Yeah, and then we'd have to like, I guess, write the new value to a register. I guess. Or like we'd have to like write it to a virtual variable, I guess, for now. And then we can like clean up the copies later down the line, maybe. But also, I feel like optimizations at this point, or at least like it's harder to clean up messes at this level. So maybe I avoid that. Maybe I just keep a register value there. But just for tree merging, maybe I shouldn't do that then. Maybe I can do something creative. I don't know. Okay. Best haircut for learning about CS? That's hard. I'm just gonna say one that fits your face shape. I think that is all that you need. Okay, so the call tree will be a little bit annoying because we will have a couple of trees, I think. We'll have to push a couple of different trees. So we want the thing that like, I guess like, so we want to, let's put this on a new layer so I can delete it easier. So we want to push caller saved registers, move params, and then we want to call. Yeah, so that's the things the call needs to do, and we're gonna need to, I think that's like 3 separate trees, to be honest, or just a bunch of different trees. Maybe call gets its own thing. It's not really a tree then, I guess. Would we have to, I think that would constitute the end of a context then, right? Yeah, I think. Yeah. Uh, good evening, Johatsu. Best hair dye for learning about CS? Huh. I mean, there's a very obvious Rust joke to be made, but I'm not gonna make it. Instead, I will say that I am doing the optimal thing, and since I am purple right now, I will say purple. There was a brief period of time that I was bleached blonde though, and that was pretty fun. But honestly, like if you, I don't know, it's annoying to maintain. So like the real answer is just natural, but this is viable. Okay, maybe we could add a generic node to handle this thing, I guess. Maybe we could just make a call node, and that will tile to something. Yeah, I think we just make a call node with a bunch of parameters. Or a call with an address, I guess? Address/label. This is really annoying. I guess we could do label. For now. So then what does this node look like? This might be a little bit silly. So I guess we just have a call. And then, so we definitely need a label. And then we need, or how are we generating labels? I guess we don't have like, oh actually no, we can keep the string for the label, I think, right? That shouldn't cause any problems. Yeah, we can just preserve the name, I think, so that should be fine. We have a label, and then we have a list of param. So this would be value, I think? And then yeah, using this we can code gen all of the calling convention stuff as well from it. If as a call, I think that necessarily means we have to eat up a bunch of nodes. Or I guess the call node is kind of boring in and of itself. So maybe this could just be a barrier. Or like a, I don't know. Let's, instruction, selection, contexts. Or at least I'm using the term context. I'm not sure if there's like a formal term. Okay, there's a bunch of slides. That's not really helpful. Okay. I guess maybe we need to, I think we could do this, but then we'd have to like create a new context with a label. Yeah, okay. This is the only thing that doesn't really map one-to-one control flow graph-wise. Because the only other things that resolve contexts are, what's it called? All terminators. So like the return is what would, I guess, end a label context. A branch would end that. A conditional branch wouldn't actually, I think, which is interesting. Or I guess we could generate it in a way that it does. I don't know. Maybe we just like generate a bunch of blocks and then we can oh right, we also need to, something I forgot about here, we need to push return target, I guess. I guess like next label. I think that's what we need. Let's look closer at the calling convention stuff for that. Is there something in here maybe? So that's the old call frame. Old call frame. Make a new call frame. Yeah, we can do this. Then we call. And then we do things. And then we restore. Okay. Oh wait, we can just jump back actually, I think, right? What does the code for Kali look like? Unwind the stack. Okay, yeah, that makes sense. Fast call. Interesting. Okay, so then we don't actually need to change a lot then actually, which is interesting. What does the Kali cleanup look like again? What is leave? Okay, Brown x86 cheat sheet. This will be monumentally useful. I know this had a thing about writing functions. Leave. Wait, so we do use leave. That's funny. Or at least I'd assume we'd have to like expand leave then. Okay, so we do parameters and then we push the rest onto stack. We then call. Okay, so then, wow, the stack exists, cool. Okay, so we make a stack frame. So when a call is executed, the address of the following instruction is pushed onto the stack. Okay. So we might need to extend the subset of assembly that we generate. We're gonna need to be a little bit more aggressive with it, I think. Okay, but that means we don't really need to we don't need an X label. So this is like what? Next. We can just, where's it stored again? It's in what is RBP again? I forgot. I thought there was like a specialized use for it. RBP, RSP, RIP. Frame pointer, okay. Frame pointer. Okay, this is, I don't understand what is happening then. Or like, where does the next instruction live? Have you considered trying for an internship at OpenAI? I looked, it's all like front-end stuff, as in like web dev. I don't really care about that, so I have not really looked into it too much beyond the surface level, but if they're doing compiler stuff, that would be great, and I would very much apply. Yeah, they do have a compiler team, that is true. I didn't see any internships though, unfortunately. Oh, this is helping me. Internship and compiler team? Yeah, I mean, I fear they might not have an internship for it open, so it'd be great if they did, don't get me wrong, but yeah. Go. Well, thank you for showing up and have a good one. Okay, so I'm still struggling to figure out where the next instruction lives, at least. It's easier to get a paid entry level gig than an internship? Really? That's kind of crazy to me. I guess like there's more people that are just like, I guess like entry level kind of, does that cut down a little bit of the slush or does it make it worse? Save registers, allocate stack space. Where does the return address? Where do we push the return address? Okay, so we as return. Oh, so we push it on first. I see. Okay. Okay, so this will be return address, and then we push the caller save regs. We can allocate space. Did have way better luck applying for new grad roles than for internships for this past summer. Interesting. Yeah, that doesn't really make a lot of sense to me. I feel like interns would be safer though, right? Or at least, actually maybe not. Because like, interns, there's a good chance they'll go to another company after maybe. Whereas like, new grad, you'd probably be pretty safe to have them for at least like 2 years maybe. I'm not sure how the business logistics works, but yeah, there's a lot of, I guess there's a lot of questions in the air there. Took new grad apps way more seriously. That makes sense, I guess. I guess it could also be that a little bit. Tailoring resumes for each app? Yeah, I mean, I feel like in the past when I did that, or like, I feel like the people that tailor resumes either are like either really trying hard or just like, or their resume has no hope to begin with. I might have done that when my resume had no hope, so I guess I haven't done that in a while, but I guess it turns out the compiler rules are all looking for roughly the same thing, so I can kind of get away with it. I'm not sure. I need to do a better job of that, though. Oh, what's good, Satuji? Good to see you. I am trying to figure out how to handle the remaining things that we have in our, what's it called? The remaining things we have in, I'm really struggling to do English here. The remaining trees that we need to create. Yeah, we have call, we have the fee instruction, which I have no idea how I'm gonna handle yet. We have the two branch instructions. Those are the remaining ones. Yeah, this is definitely not making the code easier for me to write. I think we could take a break from doing this tree stuff, ironically, and take a second to figure out how we can linearize the IR. I have some ideas on how to do that. I think it'll just be an analysis pass, which is a really funny way for this to go, but yeah, that might be the play. Or maybe we just have like a separate miscellaneous thing, I guess. I would consider fuse versus basic block param during this. I have not thought too much about that yet. I think they're just like completely different, right? Unless I'm misunderstanding what you're saying. We can definitely linearize this somehow. I'm trying to figure out how to do this. Or what the best way to linearize would be. What is linearized? Right now we have a control flow graph. I would like to make my control flow graph more of a straight line, rather than something that has a lot of, or I guess like I need to figure out a way to flatten it so that it's just like one sequential series of, I'm really struggling. My command over the English language today is like my command over water, and I cannot command water. Yeah, so we have a control flow graph in the middle end, and we want to, I guess, make that a sequential set of instructions so that we can minimize the number of jumps we have, and then, I guess, be able to put it into a file in a sequence. Function identical, just different ways of describing variables that have different values from different points. Oh, I guess that kind of makes sense, yeah. That might, yeah, I might have to think about that then. I think my plan right now is I'm gonna preserve the phi instructions, and then they're gonna get nuked in, like regalok, because then we can use the information from those to, I guess, do more stuff with the interference graph. Okay, so then where does this go? I guess we could do like linearize. Yeah, we can do that for a second. Yeah, let's make the header real quick. We can steal this stuff. Okay, so we want, maybe there's something useful in here. Yeah, okay. We want like, yeah, this is a terrible interface. I need to rewrite this eventually. But it's lasted this long, so I guess it's pretty reasonable. I don't think we need a visitor for this yet, I think. I guess we want like std list of, or we should include, what do we include here? I guess we need MIR. So a list of instruction, I guess. And this will be linearized, and this will be, this will take a program. Yeah. And this is a, oh, I need MIR. Whoops. Okay. I think that's all we need in the header actually, which is really funny. So we can go in here now. Recently learned pragmas, what is it? Pragma is like preprocessor directives, I guess. And what pragma once does is it prevents headers that have already been included from being included again, pretty much. And that is like the, if you think to like, If you've like looked inside of a C or C++ file and seen like that really gross like if def something, then like, or if ndef, and then like defines a bunch of headers, it replaces that. The only problem is that's not technically part of like C++, but so many compilers support it that I think it's like pretty safe to include at least. Okay, so we can do this now. We should include this. Middle end mir linearize, or just middle end utils linearize. Yeah, okay. So let's, I guess we don't even need the header for this. We can just implement this. Okay, so we want to list which is the result. Yes, we want that, or we want std unique pointers, right? Or we could just keep pointers actually. I think that's safe. And that avoids us having to like do a bunch of copies as well, or a lot of moves at least, which is annoying. So if we could do pointers, that'd be great. Yeah, so we can do this, and this will be the result, I guess. Or I guess like, yeah, we can do that. We'll need that eventually. So now we can iterate through this. So for each function and p get functions. For each, we need a traversal order for this, I think. What is the best way to linearize? That'll be on linearize CFG. Oh, what's good, Varun? Good to see you. I guess what is the best way to linearize this? Can't find your videos yesterday. Have to see you're doing interesting stuff. Thank you. Okay. How do we want to handle this? Maybe we iterate across all the, I guess like we need to figure out how things work at the edges. I could just like plonk it straight down, but that's not really what I want to do. So for each basic block, and or we want a traversal order here thing, I think. I'm trying to think what would make the most sense. We need to make a label instruction, which is really annoying. We might need another IR. Or maybe we just like rearrange the basic blocks, maybe? We can just like delete word. Yeah, maybe this interface doesn't make as much sense. Maybe we just reorder the basic blocks and then we can just preserve that in the function. Okay, so then that should be a transform then, right? Okay, so let's, this is very slow for some reason. Yeah, okay, so then let's take this out of utils. Let's move it into transform. Although it is technically util. I think it falls under here. Is this a problem? Is canonicalize a transform? I guess these are transforms because they do necessarily reorder things. Okay. Well then we have to write this like a pass, I guess, which will be interesting. Okay, so let's look at this header, I guess. And we can steal things like this then. Okay, so we need pass instead. And then we want class linearize. It's not really linearizing then, I guess. Yeah, so we could call it linearize. Yeah, we can just do this maybe, and then we can steal this. I don't think this needs any analyses. Maybe it needs the dominator tree, but I don't think we need it, at least at a glance. Yeah, this should be good enough, I think, for this. Yeah, okay. So then we need to restructure that as well. Can't find anything about our linearize. I'm kind of like making this up, I guess. But it's kind of just like converting the control flow graph down to a straight line set of instructions. Keep the grind. I'm making my own language now. Currently at Lexing. Good stuff. That's good to hear. Ah, okay, full blinded. Is this useful? This is not helpful. Wait, is this helpful? Huh, okay, that's not really useful for me. Okay, I'm not really sure how to approach this is the big problem. I guess we need to like think of a couple cases. So I guess straight line connections, just one-to-one, we can definitely just merge, I think. Or at least we can put those sequentially. I guess let's draw this out. Okay, so we have a node, and this is a node. These we can just put sequentially. So A, and then B, we just need sequentially, I think. So we can do like A, then B. The other two cases are, I guess we have if I can draw a circle. So we have A, and then this has two descendants. This is B and then C. This, I think the ordering should be A, and then I think we should default to, I guess like, maybe we could do something interesting here. I guess we could just do ABC for now, but this seems a little bit contrived. And I guess the big question is like, where do the descendants of that go? It's like A, B, and then like after B, I guess. And so we can do A, B, and then like, yeah. So this case makes sense. This one, I think we need to figure out like A, then... So then A and then B. And then... Oh, this is so confusing. I feel like this is a very solved problem, but I'm just struggling to recreate it from scratch. So I guess B children and then C children? Is that the sequence we want? I think this would make sense, yeah. We could do this. I guess we could set that as that for now. And then the other case is when a node has multiple, I guess multiple in nodes. So one to many, many to one. Yeah, so this would be like A, B, C, and then D. I'm probably not thinking about this correctly. Huh. Okay, this is a solved problem. I know where the solution lives. Give me a second to look it up. Because I've definitely done something like this before. So I have played these games before. Let's find it. Is it this? It's not this one, it is this one. The goal here is to minimize jumps, I guess. So I guess this is just an ordering problem then. We can generate with all the jumps and then we can do all the reorderings as we see fit. Yeah, I haven't read chat in a second, so I'm gonna chill and read that for a bit. How do you learn this? I took a class for the most part, so I know where to look. But in terms of like figuring out what is happening from here, I've been like looking at various different textbooks. I think the list of like resources, if you're curious about it, is pinned somewhere in my Discord. How do you get yourself to like coding? Just, I guess like figuring out what you enjoy about it is the big thing. Like for me, for some people it's like making something that works. That was me for a while, but I feel like for me the big thing is just like getting a deep understanding of a certain set of systems and just like becoming, I guess, very knowledgeable in all of it. So it's like, it's up to you what you find interesting about it. You just kind of have to figure that out, and then you can tailor your projects towards that at least. I also think that like computer science is distinct from it's very distinct from, I guess, what software engineering is. It would be like, I think computer science is more analogous, like computer science is to software engineering as chemistry is to like baking. It gives you like foundations for things, but it, I don't think, is a very accurate representation of like the coding experience at least. And there will be a lot of math inherently in there. So if you don't want to pursue computer science like as a college degree, then like fair enough. But if you enjoy coding to like make things, nothing precludes you from, I guess, working on things on the side and figuring out, I guess, something else to do in college proper. What hair product do you use? I get my hair professionally dyed, but I maintain it with purple shampoo. I think the brand is called Viral, if you're curious about it. Aside from that, I don't do too much. I use one of the Olaplex products, I forgot which one, and then I use some sea salt spray, and that's about it. I'm unable to even start, it looks quite daunting. Yeah, there is a lot of stuff. Luckily, I think the books are, I think the books have kind of handhold you through the starting foundations of it, and then from there you can build up. I think Crafting Interpreters is probably the best place to start though. Cranelift compiler is a nice write-up. Okay, I'll take a look at that real quick. Cranelift CFG to ordering. Let's Let's not blind ourselves. Oh wait, they also have an instruction selection post. That's really nice. Okay, so they have an SSAIR and then Cogen, okay. Legalization encodings. Single IR, oh yeah, sure. Interesting. V code. Yeah, this is basically what I'm doing, I guess. But then we need to like convert. Tree matching, okay. One-to-one, one-to-many mappings, but not many-to-one. Okay, so we define a tree. Each argument, we can look up the program to find its producer. Yeah, we do that. Either it's an ordinary value, which has one definition, or it is a block parameter that represents multiple definitions. Okay, so yeah, this is where the whole block parameter versus fee thing comes from. Okay, well, I guess this kind of answers how I handle fees then. This makes sense. If we hit a fee, then we just end at a leaf. Yeah, that seems reasonable enough for me. I think it's fair to use fees as just like tree boundaries, I guess. Let's go 360. Okay, so I guess we generate a bunch of one-to-ones. Backward pass. Okay, so this is kind of just like what I'm thinking about, but I guess this just means that we can do fees properly. Okay, let's make a new layer. Let's do fee real quick. Fee will just be a fee. I guess we can do fee. This goes into a register. Oh, okay. So we can do that. And then I think a fee will just count as a terminal. And or actually, yeah, a fee is just a fee. It really is just a fee. I guess what do fees look like in this? Or we have block parameters. So then glup. Where did I mention this again? So we have this. What does this do with, oh. I see, okay. So then if it gets to a fee, then I think that makes sense. Or I think in a fee, we could just generate a fee node and then this will, we could do like external register or something like that. Right. I'm thinking about how to reason about this. Okay, so we have wait. Oh, okay. I guess we just we don't try to merge past the fee. So like if we, I guess we can generate all of these. Yeah, this will just have like mapping from like block to, I guess we don't really have block anymore, huh? I guess we can just give it values. So just a list of value, or list of node maybe, or list of reg node. Yeah, so we can do that, and then this will take a circle, there we go, a circle, and this will be a reg. I have this big R. Okay, so this should be list of R, or I guess like we'd do like R plus, I guess. Yeah, that might be the way I represent this. Yeah, and then this will take a reg here. And this is how we represent a fee, and then this is where the barrier lies, I guess. If we hit a fee node, then I guess we just stop trying to match on it, I guess. I think the way I'll implement this is maybe I'll have like a wrapping data structure around like each tree node, and then we can keep track of, I guess, lowest level children at each one. And then if it's a fee, then there will be no children on that side, at least. I think that will be the way I handle the fee. Or at least in terms of like, once I get to like tree merging stuff. Is this its own layer? It is. Okay, perfect. So now I guess that's the big thing I took from this. This doesn't help me think about branch and then cond branch, which I guess the next thing will help me think about. I think call gets its own barrier as well. We just did a dominator tree to compute reverse post order. Wait, that's all I need? Wait, because if that's all I need, then I kind of already have that. That's really funny. Or at least it wouldn't be hard for me to do that, at least. Yeah, the thing is I want to try and optimize for fall throughs, so that might make things a little bit more interesting. I guess more specifically just the least branch instructions possible. Sorry, let me just like look through these slides real quick. Oh, I guess this makes sense actually. Okay, well, let's see what happens here. Yeah, that makes sense. So we can lay them out in this order. Yeah, this seems a little bit messy. Branch offsets. Also, supporting hot cold path annotations. That's something I'm thinking about in the future. There's a lot of... That's like an extension that I think is outside the scope currently, but I think that is something that I could add eventually given enough time. For now, I think I'll just optimize for least branch instructions and call it there. I think that will be the least awful way to go about it, at least. Yeah, there's like a fixed point algorithm to do that, so I'll probably do that. Or, minimizing branch instructions. Yeah, we need to figure out empty blocks as well. Jump threading. Splitting critical edges. Interesting. Machine specific form? Oh. Yeah, okay. Streaming edits. So I have the final block order ahead of time, that makes sense. Yeah, so this is kind of what I've been thinking about trying to do. Order and split edges while lowering. Yeah, so we want to do this in the same order so we can make less of a mess. We just need uses before defs is the bare minimum. Yeah, so post order traversal is, yeah, that makes sense. Yeah, that's readable. Okay, so this like edits on the fly is what I'm getting from this. Okay, well, I guess that could be interesting. Yeah, let me think about how I want to do this. As in, I'm going to look at slides that I've looked at in the past on the side. Okay. Does this make sense to me? Okay, well, I'll figure this out later, but I guess we could just do reverse post order for now. I'm kind of lazy. Or at least we need to like figure out how to do something here. Maybe I just like skeleton this and then leave it to do. So it's future me's problem. That might be the most sustainable way to do this. Cause why make things easy for myself? Yeah, so we want linearize, run. It should be pass or transform, linearize. Okay. Yeah, we're gonna make life regrettably annoying for myself in the future. Yeah, I guess we'll just traverse the control flow graph. I need to figure out the best, I guess, rule set for that. But yeah, I'll figure that out later. This will be start. I guess like we gotta linearize. Then okay. I think linearize will just be something that we call in the back end, regardless. So we want stood unique putter linearize, or actually we could just make linearize, right? Middle end transform linearize. So we want linear that lin, I guess we'll call it that. That should construct. So then we can do that, and then we want. Then we're gonna run on MIR. Okay, so that runs linearize, and we can worry about that later. Or rearrange basic blocks. Or I guess linearize is a misnomer, I guess. What do we call it? I guess maybe we could even just make like a machine code gen canonicalize or something like that. That could be interesting. Yeah, I'm really struggling here. Yeah, we can just say like reorder blocks, right? Reorder blocks to maximize fall through. Yeah, so we can do that. And then we need to generate trees, and then so I guess we could make like tree gen visitor, I guess. Oh, I see. So this needs P or MIR. Yeah, okay. So we can do that. And then I guess we could just iterate per function. Yeah. And then the function order should be enforced just by the code, I think, in general. I'm no expert and I appreciate the work you're putting, but I don't think a compiler should take this long to build. Well, you're probably not wrong, I think. I definitely think I could be a little bit more brisk with this, but I'm also trying to, I guess, rebuild from scratch a lot of the modern infrastructure that exists. So it's like, it'd be akin to like writing an OS in terms of the time I would have to put into it, I think. Like I could be very simple with it, but I'm trying to do this for a living, so I feel like I need to at least have a good grasp of what the modern software looks like, at least from end to end. Day one was legendary? Yeah, that was an interesting day. Okay, so we want MIR, get functions. So for each function, for each basic block, and then each instruction in it, I think we can just visit, maybe? I guess the whole pass through this feels a little bit strange. Maybe we could give like a traversal order instead then? Because I know we have like a basic block traversal order thing somewhere. And traversal, yeah. I need to clean this up as well, but yeah, maybe that will be a place I can give myself a break at least. Okay, so we added to do there. Yeah, we can generate trees per instruction. I don't want to worry about this right now. Preserve fees I have already priced in. This I think we've priced in. So we want each basic block in F, get basic blocks. What order is this traversal stuff in? What does this take? Jesus, what am I doing here? What am I doing here? Holy shit. God, that's awful. Okay, so that is per basic block. Okay, this traversal thing is like really irritating me. I think I might just slate next stream to work on that actually. This is backend stuff. This backend stuff can take a break from that. I think I need more time to just like think about how I want to implement these things. As interesting as interesting as it is to stare at me struggle to think about how to implement things, I feel like that might not be the best use of stream time, and I feel like y'all care more about like me actually writing code. So I'll probably try to save more of that for off stream, and then in the meantime I guess I could do cleanup here. Okay, so we have this. I guess we could move or place, linearize pass. Actually, let's just get rid of the linearize pass. How do I undo that commit? Git undo last commit. Yeah, let's just do that. Okay. Let's get rid of that actually. So what we're gonna do is we're gonna get rid of these two. And we will just put this in traversal, I think. I want to get rid of this stuff. Let's make a... Perfactor dependence. I think that's how you spell it. The noun, so we want the one with the A. Okay. Yeah, we're splitting hairs here. that. Yeah. Forgot I signed Chase Your Dream. Thank you, appreciate it. You're probably not wrong though. You're very much not wrong. I definitely could be doing this faster. Building C++, yes. Okay, so we also want so we want like, what would the interface for this look like, I guess? Ironically, this might be better represented with a pass. Which is very funny because I just deleted the pass that I wrote. Probably not though. I think we could just make this not a pass. It seems silly to make passes for passes, so I guess we could do it like this. So we have pre-order basic block iterator, we want reverse post order, and then we want least branch order, I guess. So this is what we want now. So we want a list of our basic block putter. Yeah, we want that, and then this should be like I guess like get least branches, and this takes in a function, I guess. F, yeah, we could do that, I guess. I guess like traverse least branches. Yeah, and then we can do the same thing up here at least. For this should be like traverse reverse post order, and then we want pre-order here. Okay. So now we have all of those. We can extend those out as we go. This numbering thing is like irritating me. But I can't think of a better way to do that, so. Yeah, that takes traversal order and then it takes traversal numbers. Oh, I guess that makes sense, yeah. We could store pairs even. I don't know, what is the best way to design this interface actually? Let's just like clean up the to-dos here real quick. Actually, no, we don't want iterators for this, to be honest. Or maybe we do, I don't know. Yeah, because it looks like we're gonna need both, so we can kinda... Yeah, and then we can do like... I don't know, like... I guess we could do the same thing here, and then we could do like number reverse post order. Yeah, it looks like that's what we want, at least here. And then we can implement it as we see fit. Yeah, so we can do that, and then we also want a... I guess we could do like number map, is what we could call it. Yeah, we'd want to call it number map, I think. So it'd be basic block to it'd be basic block to uint64. So I guess we could call this like using number map or traversal order map equals stood unordered map from just this thing. Yeah, we can do that. Let's get rid of that. Yeah, we can do that. Yeah, so we do that. Let's leave this to do there. Yeah, this is kind of just setting up for last time, I guess. So let's throw this here as well. This is all like next time tasks at least. Yeah. And real quick though, I'm gonna get rid of this because we don't need that anymore. This also just doesn't exist anymore. I do need that header, so I will steal that. Instead here we want auto linear minus equals. Alright, it's like, yeah, we can do that. This will be traverse these branches, and this will take F. Get, I think, yeah. I'm gonna do that, and then so for each basic block. Can I just deref like this? Can we do this? Is this a thing? What type is this auto then? Oh, that is just a basic block. That's really funny. Okay. Okay, so then we can like do. Or you can like make a, or we need to make the tree gen visitor up here, right? So we can do this, and this takes in F, I guess, or MIR. Oh wait, no, I already have that up here. That's nice. Maybe I could put this in the function level then. Or actually no, I want to do this once because that makes a mess out of numbering. Or as in, it's very pedantic about numbering. We only care about numbers insofar as like they're unique. So it might get ugly, but it's fine. Okay, so yeah, so we can do that for each basic block. We want for auto I in instruction in basic block, give instructions. Yeah, and then visitor visit I think, or so I accept, this takes visitor. Yeah, okay. So then we can do that, and then we're gonna reset visitor somehow. Yeah, and then we can go from here. In terms of merging trees, maybe we can just make the visitor store everything with another level of nesting, but that sounds awful. Okay, there's a lot of stuff we need to implement still. This is terrible. This is not not very enjoyable. I feel like I'm like writing homework code for someone to complete or something. Yeah, we need to figure out the rest of this, I guess. Yeah, so maybe the stream title is a little bit of a lie, but it is what it is. Yeah, we could do some look ahead stuff, I think. And then if the next one, or if it's a unconditional branch and the next block is, yeah, we can do some look ahead stuff to, I guess, generate things between basic blocks, at least for edges. And then the call, I think we'll just have to make do with. I think we can still make that work. We'll just look at some more slides real quick on the side. These were the ones that I used in the class, so I at least recognize these. And this is where a lot of my context comes from. Maybe it'd be easier if I just stuck more labels into the code though. I might have to make more labels. Okay, well, I'll figure out how to structure this later. I think I'll add a bunch of comments for myself off stream, and that will help me figure out what is happening here. Yeah, maybe I call the stream here. I'm kind of hungry. I haven't eaten dinner yet, and it has been like 6 hours. Yes, let's add all this. Let's get rid of the backend stuff real quick. It's time to figure out traversal for the next stream. I need to format it. Damn it. I guess I should also add the actual things in here, or like the little stubs in here. Yeah, so we can steal these. So we want that. Number reverse post order, I think, should also take a traversal map, or a putter to a traversal map. Yeah, so we can do order map. This will be Tom traversal order map for traversal order map. If there's anyone in chat named Tom, hi Tom. Okay, so we can do that. I think this grouping makes sense. Or at least this list of them makes sense. And then these we can just implement. We can like, yeah, we can do this. Yeah, let's just stub these out real quick. I think all of these just make a map, right? Or I might be wrong about that one. So we can do that. So we can do traversal order. reversal order, return reversal order. What happened? I see. So we can paste that in there. I accidentally copied over the buffer. Okay. So that should be all we need there. I guess we could at least get some sort of substantive code written in the stream. Let's get rid of all of these first. Maybe we could at least implement the post order numbering, just like this one. And then this could also just wrap the number one, I think. I have an interview tomorrow, I'm so nervous. Well, good luck. If you've been prepping well, then hopefully it should go well. And if it doesn't go well, then it happens, don't worry about it. Okay, we can do this. I think we could just do... We could make this call the number version. Yeah, so we could implement this real quick. Okay, so then... So we have head is F. Alright, we could... Yeah, so we want F get entry block. Yeah, so then... Actually, we could do Q. Let's do vector of mir basic block putter. Alright, so this is not a queue, this is just stack. Mic is super low? Okay, that might just be my fault. Let's mess with the mic stand. Okay, this might be a little bit better, hopefully. If not, then like, unlucky. I'll figure that out for next time. I'm grinding a lot, but it's been hard with work in school. Yeah, that's kind of how it is, unfortunately. I feel like it never eases up, but yeah. Hoping you do well. I trust you will. A bit better? Okay. Yeah, maybe, oh, wait. My OBS gain is down, but yeah, I'll fix that for next time. I can't be bothered to right now. Got one recently too? That, yeah, that is true. I will not disclose more information about it, but, yeah, I will not speak on it for the time being. Give it a week. I guess there might be an announcement in a week, I guess. That is all I will say about that. I will not speak further about it. At least for now. Okay, so we want... Yeah, we are all gonna make it. We 100% will, I believe. How do I do reverse post order again? Successor. Oh, I see how this works now. Is there an iterative algorithm for this? Maybe I'll get the same company. Who knows? That might be a cool outcome. Okay, so I guess, wait, okay. So pop, we append it. Oh, and then we just iterate through it backwards, I guess? I'll come back when I hear the news and tell you the company. Sounds good. Yeah, keep me posted if you want at least. If you don't, then like fair enough. I would. If you don't, then like don't, obviously. But yeah. I want to do this iteratively, but I feel like that's gonna be really slow. I guess this is a queue then, right? I guess we could just keep pushing front, right? And that will do that. So what is post order? Is there a good image? It's 1, 2. Or wait, 4. So yeah. 4, then 5, and 2. Okay, I see. So can we do like a push front thing maybe? I feel like we'd hit a recursion depth limit if we if we don't do this iteratively. Not that we were before. Two stacks. Oh yeah, I see. We do need 2 stacks. So we push the root, and then while it's not empty, we want to pop, and then push it to the second. And then with the left and right children. Okay. So we want to so we want auto cur equals stack, pop back. Putter. And is this the correct type? Yeah, that is the correct type. What is wrong here? F? No. Oh, wait. Stack back. Whoops. Yeah, there we go. And then stack. We're gonna pop back. Yeah, so we can do that. And then so we want to auto. We want cur. Or wait, we have this somewhere down here, right? Successor. Successor in cur, get successors. Do we need a visited map? Yeah, we need a visited, I guess. I guess we could just do. I see. Okay, we could kind of emulate what we have down here. I don't hear you well. Okay, I guess I'm not speaking directly into the mic. Huh. No, I haven't changed my mic audio settings. Maybe I'm just not speaking directly into the mic. That's on me. I'll watch the VOD back. I'll figure that out. Maybe if I turn this up. Then there's some background noise. I don't know. Let me know if y'all are fine with that at least. Better? Okay. Okay, so yeah, just let me know if the audio is not particularly great at any point, I guess. Okay, so why are you building this traversal? There's a lot of things that depend on it. The big thing is where does this come in? It comes in Dominator tree. So we need this analysis for like a bunch of other passes. The problem is the way we make this is like really ugly. So this is very gross. I don't like this at all. It's not this, I think, right? Where does traversal order come from? Oh, number post order, this thing. If there is a way I can get rid of this, that would be great. Yeah, so hopefully I can make this less awful. European? Nah, not yet. Ask again, or like, say that again in a year, and maybe my opinion will be different, but I can't really say that right now. We can kind of just copy this logic, I think. Right? Wait, this is so confusing. What is this going to be at the end? The end goal is a compiler from C down to x86-64, and with a lot of modern compiler infrastructure recreated. There's a lot of stuff that goes on, I guess, under the curtain that is infrequently talked about. So there is a lot more than meets the eye, I guess. Okay, what am I doing here? Why did I have a reverse view here? Reverse traversal order. Ugh. What was this? Are you using a NeoVim distro? It's completely... I wrote my NeoVim config from scratch. It should be somewhere in my GitHub, which should be in the description. Doing this for 77 days? Not quite. 20 of these were on LLVM's first language front-end tutorial. So that's where some of the time has gone, but the rest of it has been working on this project. Yeah, I think like days like 5 through 25 or something like that. I could be wrong about the start and end, but it's roughly around there. Those were spent on the LLVM first language front end. How do I do this? I'm gonna push back. Okay, so if there are no children, then we push that back. What is this reverse traversal order thing that I have? That seems really strange to me. I don't know why I did that. Reverse view? Just why? Why did I do that? Was this in the algorithm? Yeah, this is the SSA book. This is one of the books that I've been referencing. Where is this? This was in Dominance Frontier? No, Dominator Tree. This was not this one, actually, ironically. Let me pull this up. Is it this? Is this paper? There's pseudocode somewhere here. Reverse post order. Wait, what? Wait, what am I doing? Number post order. This is, wait, what? Wait, what am I doing? This doesn't make sense to me. So we just get the normal post order. Oh, I see. Okay. Okay. This makes sense now. So maybe I could just skip this reverse view actually. So I guess we could do post order then. Yeah, we could just do this, I think, for now, and then we can clean it up. I really don't understand what this code does, probably because I don't know the logic compilers. This is more just like a big graph traversal. Jeez, I can't speak. Big graph traversal. All you need to know about what's happening here is we have our C code. We turn it into like an optimizer language, which is like similar but not quite. Not quite C. It's closer to like assembly, and that stores the program in pretty much a directed acyclic graph. So you have these blocks of like straight line instructions, and then depending on the final instruction on those, you either return from the program or you select a next descendant, and from that you can generate a graph. The problem is we need a certain traversal order for that to run certain algorithms. So that is what this code is trying to achieve, I guess. Okay, so we can do this. If there's a way I could do reverse post order, that would be helpful. Oh, we have this regress find LCA thing. Yeah, okay. Well, I guess we need to make some changes anyway, so that will clean that up. I said I was supposed to end stream because I'm hungry, but after looking at this code, I became so disgusted that I am no longer hungry, so yeah. Is there a place you post the sources used? If you're talking about these texts, they're all on the internet somewhere. This book you can acquire through like legal or not legal means, up to you. There's the title, there's the editors. And this is a paper, just look up like Cooper, Harvey, Kennedy, dominance tree, I think. Dragon Book, I've been trying to look through that, but it's just like kind of dense, and I feel like I wasn't really getting a lot out of it. Just discovered the channel? Well, welcome. Okay. It just occurred to me that I need to... Yeah, this is just post order. So it's not reverse post order. This is just post order. So we have those. We have pre-order, we have post order. Yeah, so then we need to clean that up somehow. So we can do this. What's wrong here? Oh. Why is that broken now? Oh, I know. Get. We want to get unique edges. Okay, that's what we want. We can kind of make this work, I think. Iterative. I could just do this recursively hidden inside of this, which is really funny. I think for now I'm gonna do that, and then we're just gonna clean that up later. I don't really like this two functions thing and this like awful interface I have for this. So yeah, we're gonna try to make this suck a little bit less, hopefully. Yeah, so we want number post order. And then, yeah. So then let's go to the place where we needed this again. Yeah, so we have the function, so we can just give it the function. We don't need to pull the entry block out, I think. It looks like we're gonna need to pull it out anyway, but that's like a later issue. Okay, so let's clean this up now. Yeah, let's make a lambda, I guess. Oh, I lied. We can't use a lambda. Okay, we might have to keep this for a little bit, unfortunately. Yeah, so we're just gonna throw this here, and then we're gonna make this someone else's problem. Yeah, and then let's go back to utils, traversal header. Let's throw this down here. Yeah, so we're gonna just like change the interface of this, and this is still useful because then we have like a consistent interface across things. Okay, so we have that's a to do. That's fine. Recurse post order. This is fine. I feel like we have a pre-order traversal somewhere. I forgot where though. I think it's in Simplify? Or it's in some pass somewhere. Okay, I guess not. I'll remember where, but I think I needed it for something. Yeah, I definitely needed it for something. I don't know. Okay. So recurse post order. Let's just make this more explicit. Okay. I really don't like this though. I really hate the way I've written this. If you're wondering why I don't make this a lambda, it's because you can't recurse with lambdas, and that makes that completely infeasible. So I need to do this ugly thing. Is there a way I could do this iteratively though? Because if I could do that, that would be very, very ideal. So we can do like, real quick, I guess we can, I don't know. We need like a visited map, which is what the traversal map I guess does for us. Huh, okay, well, I guess we can just give it an empty map and then we can use that and just not return it? I'm not sure. Yeah, okay, so I guess we should just like traverse. And it should just always take a map and we could just like not use it, I guess. Or maybe no, we can keep it. We can keep it. I feel generous. Real quick, this should not be that hard to implement. This should just be like so we want like reversal order map Tom. So then we just want to return number post order. This takes in F and then Tom. Or Tom ref? Yeah, okay. So we can just do that. I would very much like to get rid of this slash up here though. So if we could avoid that in any way, that would be great. So then we can do auto entry equals f get entry block. We can make the stack, and then we can just entry, I guess. We can do that. That's a basic calculator. This should be fine. Right? Why isn't it working? Yeah, that should work. Right, or maybe we take this in as a ref, maybe? Yeah, that's what we should do. And can I just pass that in straight up like that? Okay, cool. So we can do that. I can just graft that onto this. Or actually we could. Okay, we can get rid of entry. Okay. This should still be a ref instead. I think we should change this as well to be a ref. Okay. So if we can do that. I think we need to paste this here. And then okay, I lied. We're not gonna try to be fancy with this. We're just gonna graft this straight onto that, I think. Okay, so we're gonna I hate everything about this solution. Let's do F get entry block. It's just an adapter at this point. And then we have traversal order. We give it Tom, and then 0, I guess. Is this the correct type? We should. Yeah, we can just give this traversal order map as well. That works. We can make a counter instead. Counter. Okay, that works now. Why doesn't this work? Oh, we just give it that? Okay, cool. Okay, this is rather gross, but I guess what can you do? So we have that. I guess we will add a to do here. Yeah, we can do that, I guess. And then this is fine. So you need to implement least branches, and we need to implement pre-order, I guess. But this is nice because we have replaced one interface with another interface that does the exact same thing. So have we really gotten anywhere? I don't think so. We can definitely hide that though, I think, in the header. So I mean, that's a win maybe. Yeah, let's look through all these again. Yeah, we can do like, let's just delete this without motions, I guess. Do that. I can do that, and then this equals, I guess we can do like auto traversal order equals traverse post order? Yeah, because we want reverse post order. And then we just give it F, I guess. Or f.get, rather. Yeah, okay, so then we don't need this anymore. Yeah, so we can do this. This is all setup stuff. This all seems fine. I hope all this builds. Let's build. Something might also just break somewhere, which would be very unfortunate. MR to LR, returning void. Okay, that makes sense. Let's make test. Okay, so we have an infinite loop in something. I might have fucked up something here. Uh-oh. Make file grind, debug bin tests, or regression tests. Let it run for a second, it might just infinite. Interesting, it's, I guess it makes sense this breaking here. Why is this breaking here? Dominator tree run. Are we not reaching a fixed point? Or, oh. Oh, we want number post order, I think. Right? Yeah, okay, that's what we want. Number post order, we want F, and then we want traversal numbers. Let's rebuild this. I think this should work now if we build tests. Okay, perfect. So let's commit some stuff. Update traversal interface plus scaffold some to-dos. And then fix DT traversal dependency. Yeah, this also cleaned up the code a little bit, which makes me happy because now this is readable again. What did I change? Scaffold, MIR to LIR, a little bit more. Okay. Let me just like write down a sticky note of stuff that I should look at off stream because I'm really hungry. Okay, I guess we could start with this page. I think all of these we can keep as, or at least like with the tree gen. Yeah, because they will also be sequential, so I think this is sufficiently fine. I think this also means that we've kind of thought through how these nodes will be worked on, at least. I kind of like this. I think we should have a way to generate label. I think we should have a way to generate labels. Yeah, the call should also just like push a label on, I think. Or maybe we should, yeah, we want call label and then next label. And this will just simplify the calling convention a little bit, I think. Or ret label. Oh man, okay, we're making a mess with the annotate. Oh, it's all in the wrong layer. Oh fuck, okay. Okay, so this is layer 2? Yeah, okay. So let's use an eraser. Let's pull out the damn eraser. Okay, so let's get rid of that. So this should be return label, I guess. And So we want to push the return label address, I guess. Right? Yeah. Or we can just push that, yeah. We can push the return label, push caller saved reg. We can remove the params, call label, and then we want to label. I guess ret label. Yeah, okay. So I think that's what the call needs to do at least. We can take this pile and we can move it somewhere more fitting. And all of this, just for reference for myself, because I'm going to forget, this all goes here. Yes, this all applies to call. Okay, so this one we can merge down. The fee, I think I feel pretty comfortable with. Branch and con branch, I think we might need a little bit of logic for. Let's to do this. Yeah, because these will require more complex logic, just for like barrier related reasons. The code gen's like a little bit more complex if we have like if we're trying to, I guess, optimize for like fall throughs at least. So that's a consideration. We could also just like leave the fall throughs unoptimized and then like people optimize them later. I think that's something that might also be easy, but that might actually be the smart way to do it. Because if we're gonna optimize it out anyway, we may as well just do it once. Yeah, actually. Actually, maybe we just do it once. I don't know. I'll figure it out. Let's just flatten this. I'm gonna put this in my Discord, which, by the way, if you have not joined, you should definitely join. It's in the description. It's the best place to stay up to date with when I go. Stay up to date with. I'm getting my words mixed up. Best place to get pinged when I go live, and then chat with me in the broader community. Everyone is really chill, and everyone is quite smart. Just throw this in here. Yeah, and then I'll figure out this for myself as well. What's the Goovier? I'm about to end stream, unfortunately, but I'm doing well. Hopefully you're doing well as well. I'm just writing notes for stuff I should think about. I should think about fall through, optimization, logic. I should think about what else? I think tree merging. I think those are the two big ones. If I think of more, I'll write them down for myself and think about them, I guess. I've been trying to join for the last 5 days, but every day timing's mismatched. I'm like, that's tough. Yeah, I fear I'm going to have to call the stream here today, though. I'm really, really hungry. I haven't eaten in like 6 hours, roughly, maybe 7, 6, 7. I don't know. Anyway, thank you all so much for watching, especially if you've been here for the whole. How long has this stream been? It's been a little bit over 2 hours, damn. Yeah, especially if you've been here for the past 2 hours. That's a lot of time out of your day, and I want to recognize that. Make sure to like the stream if you haven't, and sub to my channel. It really helps out with the algorithm, and it helps get my content out to more people. I gave the Discord spiel before. I'm not going to give it again, but join it if you haven't. It's in the description. And make sure you connect with me on LinkedIn and add me on GitHub to stay up to date with what I'm doing. That is where that line goes. Yeah, I'm gonna go get food now. Take care, y'all. Take it easy, and have a wonderful rest of your day wherever you are.